So we took this test on topics of suspension of belief and straightforward appearance, and we took this online. People got their grades and their scores, and some people were a little bit concerned because they didn't understand how they got the wrong answer. So let's take a look at these to see what is going on here and what is the right answer or the wrong answer or not. So it says there were three questions, and question number 1 and question number 3 had 2 parts, so there were 5 answers altogether. Each one was worth 20 points. So it says here, please use math, logic, and/or common sense in order to answer the following. So number 1, 2 cars, vehicle A and vehicle B, are competing in a 2-lap race on a 1-mile oval track. They start at the same time, and vehicle A finishes the 2 laps at an average speed of 60 miles an hour. Vehicle B has a slow start and averages 30 miles an hour for the first lap of the race. So question 1A, how fast must vehicle B now go during the rest of the race in order to finish in a tie with vehicle A? So let's look and see, what does this mean? All right, here's our track. So that's our oval track. It's 1 mile around this. So they start right here. So here's vehicle A. Vehicle A goes around the track the first time, 60 miles an hour. Then it goes around the track the second time, 60 miles an hour. Average speed, 60 miles per hour. All right. Then we have vehicle B. Vehicle B goes around the track 1 time, and it's 30 miles per hour. Now, how fast does B need to go around the track the second time in order to catch and tie with vehicle number A? Well, if vehicle B goes 90 miles an hour around the track the second time, 120 divided by 2 equals to 60 miles per hour. So we can see that the answer here is 90 miles an hour. Then part B is, how fast must vehicle B now go during the rest of the race in order to finish in a tie? Then the second part is, what is the minimum average speed in units of 1 miles per hour, which vehicle B must go in order to cross the finish line before vehicle A? Well, if vehicle B goes 91 miles an hour on this second lap, then vehicle B will pass and win the race. Does that make sense? Is that? Oh, wait a minute. You said that and you got it wrong. Did I make a mistake in correcting these? Well, let's look at it. Yeah, this seems to be common sense here, but let's stop and consider, because we can't average averages. So this is 1 mile. So if vehicle A goes 60 miles an hour, that's 1 mile per minute. So that means it's 1 minute for vehicle A to do the first lap. Vehicle B does the second lap. That's another minute. So in order for vehicle A to do the two laps, that's 2 minutes. Now vehicle B went 30 miles an hour during that first lap. So 30 miles an hour during that first lap equals to 2 minutes. So this means that when vehicle B does that first lap, vehicle A is already finished. So this means that it's impossible. It's impossible for vehicle B to catch vehicle A because already 2 minutes have elapsed during that time. So part B, how fast can, well, if this is impossible, then this is impossible. So the right answer for number 1 is, it's impossible. And number 1B, it's also impossible. All right, so that was that one. Number 2, it says compute the following and then show your work. Divide 30 by 1/2 and add 10. All right, so we're going to divide 30 by 1/2 equals to 15, and then we add 10, and that equals to 25. Is that the answer that you got? Yeah, then why was it marked wrong? Well, because this is dividing 30 by 2. So this divides 30 by 2. We needed to divide 30 by 1/2, which equals to, how many halves are there in 30? There's 60, right? So there's 60 halves in 30 plus 10 equals to 70. So the right answer for that one was 70. So let's look at the last one then. It says you are a contestant on a quiz show, and you will be given the grand prize if you choose which of 3 doors that prize is behind. So you choose door number 1. Then following the usual procedure for the show, the quiz show host, who knows where the grand prize is, opens door number 2 to show that nothing is behind it. Now the host offers you a chance to change your selection to door number 3. So, would you stick with your choice of door number 1, or would you change your choice to door number 3? Explain the reasons for your decision. So what do we have here? We have 3 doors. What are the odds that we can choose the correct door on the first attempt? We have 1 chance out of 3, right? So we have 1 chance out of 3. Now what's happened here is you've chosen door number 1. What are the odds that you are correct? You have 1 chance out of 3. What are the odds that you're incorrect? Incorrect. The chances are 2 out of 3. So you have a 33% chance of being right and a 66 or 67% chance of being wrong. Now, the host, because he knows where it is, the host says, oh look, it's not here. So would you change now, would you change to number 3, or would you stick with number 1? And maybe you said, well, I'll stick with number 1 because your first guess is usually right. Or I would choose with number 1 because I would really feel stupid if I changed to number 3 and I found out it was number 1. Or many people said, well, I would choose I would stick with this because the host is trying to fool me and try to get me to change, and I'm not going to be fooled by all that, right? But remember, for this class, we're looking at things in an objective and rational way. Those all have to do with my feelings, my perceptions, and things like that. Rationally and objectively, then this would be the better choice. Why is that? Well, let's look at 3B. For your final choice between door number 1 and door number 3, what are the odds that you will win the grand prize by choosing door number 1? What are the odds of being behind door number 3? So here, many of you said, well, I can either choose door number 1 or I can choose door number 3. That looks like 1 out of 2, 50% chance, which is not correct because you have a 66% chance that it's behind door number 3. Because this choice or this decision that was done by the host is not a random choice. He knew which one the prize was behind, so he showed us that one, which means now there's a 2/3 chance it's behind this door, only 1/3 chance behind that door. So you should change over there, not because of the feelings that are involved or not because of your emotions that are involved or something like that. That's why you should change over there, because the odds are that there's a 2 chances out of 3 that this is the right one to choose, switching over there. So if you said, I would stick with my choice because it's your first intuition is usually best, or I don't want to change my mind or something like that, I would look wishy-washy, or I would look weak. then that's not a good rational and logical way according to what we've been doing here in our course. So, with this in mind, let's take a look at and see, and let's do a survey, to check one of these kinds of things that are common sense that we all believe, but maybe we never stop to think about. So imagine that your rich uncle told you that he's really proud of how hard you're studying in school and everything like that, and your rich uncle said he's going to buy you a new car. So you're really excited because your rich uncle always drives Mercedes and Lexus and things like that. So then he tells you, yeah, here's your new car, and you go out there and you look at it, and it's a Hyundai. Why didn't he get you a Lexus? Isn't that what you would want? Why would you want a Lexus instead of a Hyundai? Why do people prefer a Lexus over a Hyundai? It costs more, right? The Lexus costs more because it's better quality. So we have this understanding that as quality increases, then price increases. So if something costs more, that reflects the higher quality. If something doesn't cost so much, it's because the quality is not so good. Is this really true? Let's test this. We would like to do a survey or do an activity now to test, does quality reflect price? So as the price goes up, the quality goes up. As the quality goes up, the price goes up. So is that the case or not? So what we're going to do is we're going to do a taste test survey. So we're going to find out, as the price of a food product goes up, does the quality go up based upon taste preference? So what we're going to do is we're going to do this with salsa. We know that students like to have parties, especially at the end of the quarter or during the holidays, the spring break, something like that. So if you're going to have a party and you're going to serve salsa, so should you go out and buy the most expensive salsa because then your guests will feel better? Or if you're going to attend the party, should you bring an expensive salsa so maybe you get invited again next time? So how do we balance off cost versus price? So we're going to take a look and we're going to do some taste testing on some salsa, because we know that as the price goes up, the taste and the quality of the salsa should go up too. So what we're going to do is we're going to look at the relationship between, we're going to take a look at the relationship between cost and quality, taste and cost. So what we're going to do is we'll do a taste test sampling of this, and then we're going to rank them according to taste. So we're going to find out, and we'll probably do about 12 different samples. So we'll do a sampling of 12 different ones, and we're going to be able to do a taste test to see which one is the best tasting one. Then we're going to compare that to the cost. And what do we expect? Well, if this is true, then we know that our expectation is that the one that tastes the best is the one that costs the worst. In other words, the most expensive. So this will be the most expensive. And the one that tastes the worst is going to be the one that costs the least. So this will be the cheapest. So we can figure that the best costing one is the one we have to pay, that we pay less money for. And the best, and of course the best tasting one here. So we can imagine that, we can anticipate that the one that tastes the best is going to be the most expensive, and the one that tastes the worst is going to be the cheapest, and in the middle as we go. So if we can find out the cost and rank these by cost, from cheapest is best to most expensive is worst, and then we can take a look at the best tasting one to the worst tasting one. So if we add these together, So the best tasting one and the least and most expensive one, if we add that together, it should add up to 13. So if we add these together, then the rankings should add up to about 13. And if the rankings add up to 13, we'll say plus or minus 3. So from our score of 10 to 16. So when we add these up, if we have 12 of these, then we can imagine that as we add them together, they'll all be clustered somewhere here in this range of between 10 and 16 as we sum up these ranks. Now, if we find that 1/3 of them are in this range, and then between 1 to 9, and then between 17 to 24, because if the worst tasting one is the most expensive, that would add up to 24, so that'd be a maximum. If we find that 1/3 is here, but if we find that 2/3 are over here, then what about our research question or our claim that quality reflects price? We'll find that this is then invalidated. If we find that the majority of them are in this range, then we'll find that that does validate this kind of belief of common sense, or what seems to be straightforward on the surface seems to be one way. But just as we saw, if we just look at these 3 questions here and look at them, if we sit down and actually compute it, we find that maybe that's not the case. But is it the case like this? We'll find that out. So if you go to the website and look at the module on the survey, we're going to do this survey on our own. So I'm going to ask students to go out to a grocery store or supermarket and do a survey of what sauces are out there that we could possibly use for this. We'll take a look at some of the results that were done by a previous class, and then see how those results either confirm or invalidate this belief. Thank you.